Good evening, Zimbabwe. Welcome back to BST African Electronic Surgery. Let's continue the story with the laptop motherboards. We explained some few things on part 1, the power sequence from the charging input going to the battery, and we explain how power supplies work on a laptop motherboard. So let's move on. I know theory is so boring, but I think it's a good point to start with some little bit of theory, not too much. We're not going to speak too many things, just to get the basics, and then we'll move on with our practical things. So tonight, let's continue. If you remember, we explained that the input circuit from the charging port to the battery, and all the power supply 1 volts for the graphics, and processor 3.3 volts for the microcontroller, and 1.5 volts for the RAM, that's the RAM voltage, 5 volts, that's the USB and the hard drive. So let's close this, let's open a new. So in most cases, after checking the 19 volts on all power supplies and you are satisfied that you have 19 volts, what is the next step? That's where we want to go. We want to explain about the 3.3 and 5 volts power supply, because 99% of the problems come from this power supply, or the problems that you see on motherboard are related with this power supply I'm going to explain. So 3.3 volts and 5 volts power supply. Yes. So let's start here. Let's start from the after the 2 MOSFETs on the current sensor. From the VCC pin, VCC, that's 19 volts after the 2 MOSFETs. Let's start from this point and explain further in detail to what happened on the 3 volts and 5 volts power supply. Because this power supply, mostly they are together. You see 2 coils, 4 MOSFETs like in driver. Sometimes you see some dual MOSFETs. Sometimes you see just a chip. The MOSFET will be inside the chip. So I will explain further what really happened there. So from the VCC, what do we have? We have some ceramic capacitors. Can be, like I said, can be 3, can be 2. That's not important. So I'll draw the ceramic capacitors here. One side is connected to 19 volts, and the other side, that's the ground. These are the ceramic capacitors on the main power rail, 19 volts power rail. So after the MOSFETs, what do we have? After the ceramic capacitor, we do have I want to make this thing smaller so that it will fit on my screen. That's our first MOSFET. Let me make this paint bigger. 3px, that's fine. Or 4px. That's the MOSFET. MOSFET, like I said, is just a switch, nothing special. It is a switch. 4 pins together. 4 pins together. That's 4 pins together. And here we have 3 pins together. And here we have another MOSFET. 3 pins together. And our gate. Here we do have gate. What do we have here? We have our driver. Now we'll use the common driver 51225. 51225 IC. Can be 51125, can be 1225C, can be 12253. There are so many configurations on this driver, but they are doing the same thing. So in this case, I'll choose 51225 IC. The gate is coming here to the chip, and this one to the chip, and from here we have our coil. Let me rub. I don't want this thing to look bigger. We have our coil. That's the coil. Let's put it in symbol C. After the coil, we have the output capacitor. That's our capacitor on the output. Electrolyte capacitor plus, and that's the minus. From here, we have 3.3 volts. But before this 3.3, this chip has to know what is happening on the output. So here we have a current sensor which is giving feedback to the chip. That's FB for feedback, because this chip has to know what is happening on the output. So if there's any short or under voltage or over voltage, this current sensor will send signal to this chip to cut down the power. So this chip, okay, let me finish. And here the source is connected to this, and on the other side of the second MOSFET is also a switch, nothing special. We have 4 pins together and they are connected to ground. I think that's clear. So opening and closing these switches will create voltage here. The output voltage 3.3 volts, because this chip is there to regulate voltage on the output. If you check on only one of these pins, there's V in. You see there's V in, which is 19 volts. And if you check and you find 19 volts on the chip, and you see here there's no output, probably this chip is dead. So let's go on the other side. What do we have here? Same thing. We have some ceramic capacitors which are connected to ground. On the 19 volts power rail, our voltage is coming this direction. Here is coming this direction. So from here we have MOSFET. That's our MOSFET. Same thing. Here we have another MOSFET. I'll call this one M to the power 1, M to the power 2. That's M to the power 3 and M to the power 4. There's nothing complicated here. So 4 pins together, and here what we have? We have gate coming to the chip. Here we have 3 pins together. On the other side we have 3 pins together, and our gate is coming here. That's the gate. That's our gate. Gate. That's clear. And from the chip we have coil. That's our coil. After the coil, what do we have? We have a capacitor on the output. That's plus, and that's the minus of the capacitor. After that, we have a 5 volts. Before this, we have also feedback, like the way we explained on the other side. That's our feedback. Current sensor, because this chip also have to know what is happening on the output of the 5 volts. So this chip is supplying. Here we have, I'll call it number 1, is supplying 3.3 volts, probably for the PCH, and for the switch button. That's for the switch, for the PCH. That is very clear. From this 3.3, our PCH and the switch is getting power. Switch button, you know, the power on button. After that, on the other side, that's another output, the second output too. So 5 volts here is for the hard drive HDD, for the USB, yes, and here what this chip also is doing, we have VREC 3.3 volts and VREC 5.5 volts. 5 volts, sorry. So here, that's the third output. That's output number 3 and output number 4. So if you check here on the first output 3.3, you can see there are some capacitors here. I will show you after this. I will show you the motherboard, all these things which I'm explaining here. So if you check here and we check here, the output of the 5 volts power supply in 3.3, and there's no short, but this chip is still giving you some problem. Check this 3.3 and 5 volts. That's a good point to check, because sometimes we check here, you see there's no short. Here there's no short, but this chip is getting super hot. Probably from here we have a short, because from this point, like I said, from the VREC 3, one second, from the VREC 3, our super IO is getting power from the VREC 3. Our super IO is getting power, and the easiest way to find this power supply here, let's connect our BIOS chip. That's the BIOS chip. That's our BIOS chip with a chip with 8 pins. That's our BIOS chip. BIOS chip. That's our BIOS. So pin number 4 is ground. We'll call this one P4 is ground, and pin number 8 is the VCC pin, 3.3 VCC pin, 3.3 volts VCC pin, and this pin is going straight to the microcontroller, to the startup chip. So that's another way of checking for this 3.3 and 5 volts power supply. You check from the last pin of the BIOS chip, that's pin number 8. You check, you put your multimeter on the continuity mode and check 2 coils. That's a good point to start. If you see your test meter 00, that will be the 3.3 volts power supply, and if we find the 3.3, that should be also 5 volts power supply on 99% of the laptops. The schematics is just the same. So pin number 8 is going to the chip, and pin number 8 is getting voltage from the VREC 3, not from here, no, from the VREC 3. Our BIOS chip is getting power. What this BIOS chip is doing, our BIOS chip is keeping BIOS settings alive through the BIOS battery. The BIOS battery, which is connected to 3.3 volts, is keeping BIOS settings on this chip alive. So I think that's clear. So most of the problems, or 80% or 90% of the problems, come to this chip or are related to this chip 51225. I see. I think that's the name. 1 second. 1 second. 51225. 1225 IC 51225 IC. Let me check something online, 1 second. Let me check something online. Five 1225 or motherboard 51225. Okay, or it's 51125 51125 IC chip. IC chip data sheet. One second, I just found something that I want to show you. I want to show you something online. Can be 51125 or 51225. Input, you see dual step down controller, 5 volts and 3.3. That's our chip. That's the one. That the chip can be TP, check here, TPS 51225, TPS 51225B, or can be TPS 51125. That's the chip. And how can I do it? Can I edit this one? I think I can't. But from here you can see VREC 3 and VREC 5. And that's our feedback. Pin number 2, that's our feedback. Because this chip has to know what is happening on the output. So our feedback will send a signal just to highlight if everything is okay on the output. Otherwise it will cut down the power. That's our regulator. That's our regulator. Okay, so we explain most of the problems come from this chip or related to this power supply 3.3. So after checking the first step, after checking the 19 volts, after the 2 MOSFETs, check on these ceramic capacitors. You see these ceramic capacitors, they are connected to 19 volts. One side is ground and one side is plus. Check to see if we do have 19 volts. If we have 19 volts on all the power supply, the second step is to come to this to this microcontroller. Every board has got this Super I/O chip. If you can't find the BIOS chip close to this controller, there are some caps here. There are some capacitors which one side is connected to 3.3, one side is to ground. You see, I'm sure you see 4 or 5 capacitors around this chip. If you don't have the BIOS chip, You can check from the plus of these capacitors to coils to check for the 3.3 power supply, or you check from the BIOS chip, because on new boards this BIOS chip is inside the microcontroller. You can't check from the pin number 8 of the BIOS chip. So if you find 3.3 and 19 volts, those are the conditions to start up a motherboard. So if you have 19 and you have 3.3, you try to power on the laptop, and your laptop is not starting, probably this chip is dead. This controller is dead. So that's the thing, actually. That's the thing. And on the BIOS, what the BIOS chip is doing, the BIOS chip is there to keep BIOS settings alive. And on the BIOS side, the BIOS, you can have corrupt or operating system. Your operating system can be corrupt, or the program on the BIOS chip can get corrupt, but it's very rare to see a dead BIOS chip. I never found like a shorted BIOS chip. I never found one from my history of fixing laptop motherboards. But what I found in some cases whereby the customer forgot BIOS password. You take out the BIOS chip, you flash it and reload the software, things like that. But to get a shorted BIOS chip, I never found one in my life. It's nearly zero chances of getting a shorted BIOS chip. But the firmware on the BIOS chip can be corrupt. Can be. So that's how things work on laptop motherboards. That's how things work. And on the screen side, on the screen, let me take my 19 volts from here, from the main volts power rail. Let's go down. Let's jump this. That's the LED screen. Mostly laptops are using LED screen. What is important on the screen is two voltages, 19 volts and 3.3. 3.3 volts. We have two signal. We have the LED enable and LED power, PW. Let me call it PW. So on the screen, what I'm looking mostly, if we have the backlights, the laptop is coming on, but you don't have backlight, check for this signal. Check for 19 volts and 3.3. On 3.3, check. I'm sure on the back of the screen we have some test points there for this LED enable and LED power. Check if we have 3.3. In most cases, you find out one of these signals is missing, and in that way, your screen will come on, but there will be no backlights. So what I'm doing to fix, I'm taking 3.3 from here. From here, I'll come here. I'll solder a wire here, I'll jump to this point. Because if I don't have backlights, and my 3.3 is missing, probably is missing from the startup chip. So to replace the microcontroller is too long, and like I said, we are in Africa, the spaces are so hard. So I just come with a wire and I'll jump, and in that way you bring back the backlights. So that's what I'm doing on the screen side. On the LCD screen, the backlight inverter is separate. I can't even explain about those ones because they are no longer common. Most of the screens of nowadays, they are LEDs, not LCD. So I think I explained a lot, and yeah, that's how things works on laptop motherboards. That's how things works on laptop. I think I'll combine some practical lessons where I will not be fixing anything, but I will be just explaining what really going on laptop motherboards. But I just have a few motherboards here. Maybe you can see this power supply, this dual power supply, 3.3 and 5 volts power supply. You can see here, I'm sure you can see 2 coils, more like MOSFETs 4. Like here, you see these MOSFETs 1, 2, 3, 4, like 1, 2, 3, 4, and the capacitor on the output like 2, 1, 2, and the driver is missing. I think it was used for other boards, and some ceramic capacitors. These are connected on the main 19 volts power rail. They are on the 19 volts. That's our controller, and this is the new model. Here we can see the BIOS chip, but I don't think this BIOS chip has anything to do with this controller. I think this BIOS chip is for the PCH inside the processor. This is the kind of ITE. I think the BIOS is inside, but I'm not going to test because I'm doing theory only today. Let's take another one. Check here, 2 coils, output capacitors, MOSFETs 1, 2, 3, 4, like 4. The capacitors on the output, on the main 19 volts power rail, on the input, sorry, they are connected on the 19 volts power rail. That's the driver. You can see these capacitors. That's where you find VREC 3 and VREC 5 here. That's our chip. Okay. I don't even want to see this one. What about on this one? We have some coils. I'm sure here we do have 3 coils. I can see one of the coils going to the charging, that's for the charging circuit input, and the other coils, you can see coils, MOSFETs, and on the other side we have another MOSFETs on the output capacitors. And these capacitors, ceramic, they are on the main 19 volts power rail. So the driver again is not there. You are seeing this is the second board without the controller. So that is the main problem, or 99 of the problems comes from this controller. Where is our startup chip? That's our ITE, that's the startup chip. Here we have a BIOS chip. Okay. We shall check with the test meter when we'll be doing practical. I'm just doing theory here. We have some coils. On this one, I think you can see 2 coils, output capacitor, MOSFET. On the other side, because we have another MOSFET, 2, like 4. These capacitors on the main input 19 volts power rail. The other side is 19 and the other side is ground. And here we have our driver for the power supply. That's the 3.3 and 5 volts regulator. I think that's clear. So I just finished explain few things, because many people, they don't understand what's really going on laptop motherboards. So I think that is clear. I cleared out that issue. So we shall do some practical exercise testing from the charging circuit. How to find out those two MOSFETs and ceramic capacitors? How do you find out the regulator for 3.3 and 5 volts? So yeah, I think I explained everything. I don't think I missed anything here. 3.3, 5 volts, VREC 3, VREC 5. And like I said, it's not always the case to find the 51125. Can be 51125, can be 51125, can be 51123, can be 1225C or B. You find out different configuration. It's not always the case. And on the controller, can be ITE, can be SM, SC, can be Winbond, can be ENE. On some new model of laptops, they are writing by name. I found some written Lenovo. You can find one written Lenovo as a microcontroller on some new kind of model of laptops. I found some. So you can, here you can see different configuration. So it's not always the case that you find the ITE. No, it doesn't work like that. And on the 5 volts, from the VREC 5, what we have on the 5 volts, we have a chip which is also acting as a switch. And after the switch, we have the output capacitor. That's the output capacitor connected to minus and plus. And after that, we have 4 pins of the USB. That's the USB, power to the USB. We have plus, 1 pin is plus, 1 pin minus, and some data pins, like 4 pins. 1 pin on the plus, 1 pin on the minus, and some 2 data pins. So that's how things works. If anything, you know, customers, they are playing with USB. If anything wrong here on the USB, this chip will cut down the power. I'll show you this chip. You can see these are USB ports. That's the USB, and next to USB, that's the chip. It's there to protect the motherboard in short circuits in line with the USBs. This chip. Let's take another one. Here I can't see it. Okay, you can see, look on the configuration. These are the USB ports. On the plus, that's the plus, you can see a big power rail, and it's coming to this MOSFET. You think it's a MOSFET. It is a switch which is cutting down any short circuit from the USB. This chip. Let's take another one. USB ports again. We have the output capacitor which is on the plus, and here we have our chip. It's a chip, there's nothing special. If you found a blown up chip like this, You can even short it with a wire. You just eliminate the gate and short from the drain to source. Nothing will happen. Your USB will still work fine. That's the driver to protect short circuits from the USB ports. On this one, I can't find it. I can't find it by visual eyes. Probably I need to test from the plus of the charging port to see where my 5 volts is going. So yeah, I explained a lot, and we'll try to push these lessons further, because many people they don't understand things, especially from my country. A lot of technicians or people who are claiming to be technicians, they are not doing these things in a proper way. You see, person doesn't have a multimeter, doesn't have a switch, adjustable power supply. The customer came with a device. No, my laptop is dead. He don't even open the laptop. He has nothing to check. The next thing, you condemn the motherboard, that this one is beyond repair. You need to look for another motherboard. No, it doesn't work like that. In the future, we'll explain some faults which are fixable and faults which are not fixable. Of course, not all faults which are fixable. But if you don't really know the fault, it's not a good thing to condemn the gadget from a customer. Because trust me, I fixed a lot of laptops which came from another technicians, and they call the customer, your gadget is no longer fixable, and they'll bring it here, we fix, which is not good. Let's try to be professional. I'm not saying I'm professional, but let's try to know the basics of how things works. In that way, you have the confidence to condemn a gadget or to give final say to the gadget. If you don't have knowledge, don't give final say to the gadget. That's very wrong. Because I fix a lot of devices, trust me, a lot of gadgets which were condemned by other technicians. Why? Because they don't really know what's going on the motherboard. So let's try to buy some basic tools, just some test meters, switching power supply. You know, this adjustable power supply. This one you can get it on AliExpress. It's not an expensive thing. This one, I think I bought it like $30-40 US, and you can stretch up to 60 volts, 5 amps. You can test anything here. You can test anything. So try to grab one, and a cheap multimeter, something like this, because you can't condemn the gadget while at least you don't have enough tools to test. How do you know where your fault exactly if you don't have the tools to test? So sorry, I'm not shouting, but I'm trying to push some technicians, especially on my country, more on the professional side. So I think I explained a lot. We shall do some practical exercise, and yeah, I'm quite happy. Our channel is growing. We are getting new subscribers almost on a daily basis. That means learning is taking place, and all what I can say is to like and subscribe for more videos. Also, just follow our channel. After subscribing, try to follow our tutorials. Probably at one point you will find something useful there. I'm not saying I'm the best tech. No, I'm not, but I'm trying to bring what is happening on international level in my country, because I'm sure in my country, I was checking, I've never seen anyone doing such kind of tutorials on YouTube, but I found a gap which I need to fill just to represent my country. So what can I say? Just a good night. See you on the next one. Bye.